What we can make is limited not only by the materials we have available, but also by the manufacturing tools and techniques we have available. 3D printing is a new manufacturing tool which will make new things possible and which may disrupt existing businesses. So what exactly is 3D printing? 3D printing, also known as additive manufacturing, is a class of technologies which produce 3D objects from digital CAD files by building them up one thin layer at a time. 3D printing has been widely used for rapid prototyping, and in this capacity has revolutionized the design process for many companies. However, it's now capable of much more. It is now possible to produce finished parts and products in a wide range of materials, including plastic, ceramic, metal, and even food. 3D printing is now a viable manufacturing tool with distinct advantages and disadvantages compared to traditional tools. Two major barriers for the production of parts by 3D printing have been product quality and production speed. The case studies show that these barriers are starting to fall. The first company I would like to talk to you about today is Aerojet Rocketdyne. In June of 2014, they test-fired a Phantom rocket engine entirely produced using 3D printing. Now, 3D printing has some special qualities, and one of those is that with 3D printing, unlike traditional manufacturing techniques, complexity is free. This means you can omit unnecessary material, and you may be able to make complicated assemblies as a single item. For instance, in the case of the rocket, it was printed in 3 parts rather than the dozens typically used. This reduced the time for design and construction to a couple of months from over a year and reduced the cost 65%. As a result, Aerojet Rocketdyne has received $11.75 million contract with the Air Force for the development and demonstration of large-scale manufacturing using 3D printing techniques. Now, the other company I'm going to talk to you about today is one I'm sure you all know, which is Google. Google has announced that they plan to start producing custom modular smartphones in 2015. You'll be able to specify the looks and functionality of your phone and upgrade individual components over time. For instance, you could replace the camera. Now, to make this possible, they need to be able to produce custom smartphone bodies at industrial scale. So they've partnered with 3D Systems, one of the leaders in 3D printing technology. 3D Systems has developed a 3D printing production line, which is 50 times faster than previous 3D printing systems, achieving speeds comparable to injection molding. This makes 3D printing a viable mass production technology, not just for smartphones, but for other consumer goods as well. And it enables mass customization and just-in-time, high-volume manufacturing. Other topics covered in the report include FDA-approved implanted medical devices produced using 3D printing, bioprinted tissues and their applications in drug testing, and 3D printed food, which is spectacular to look at. Now, one of the other special properties of 3D printing is flattened economies of scale. With 3D printing, there are no tooling costs. So it's possible to make 100 or 1,000,000 of items of a product at a similar per unit cost. This lowers the cost of items which must be customized, such as dental crowns and hearing aid shells, most of which are already produced using 3D printing technology. It also allows the inexpensive customization of mass-produced items, such as cell phones. Other impacts include speeding the innovation cycle and lowering barriers to entry into markets, which can be good or bad depending on whether you're the person already in that market. And then finally, the flattened economies of scale change the logistics equation. If it costs the same to make a few of an item as very many, it may no longer make sense to produce all of your product in one central factory and ship it all over the world. Rather, you may want to have many production centers, which are located close to your customers. 3D printing has grown dramatically in recent years, and that trend will only accelerate with increasing production speed. The 3D printing market was worth $3.1 billion in 2013, up 35% from the previous year. And sales volumes are growing even more dramatically. 9,800 industrial and 56,000 consumer and enterprise printers were sold in 2013, and those sales are expected to increase by as much as 100% annually in coming years. By changing how we make things, 3D printing creates new possibilities for what we can make. And meanwhile, flattened economies of scale may disrupt existing business models and businesses.
So what you've seen here are disruptive technologies that we have identified as having real commercial potential. These are not pipe dreams. There are real startups and inventors working on ideas as disruptive as the internet has been in decades past. If any of these technologies have been of particular interest, we'd be happy to chat with you about how we might be able to work to explore some of these technologies. In fact, what you've seen here is a sample of Prescatter's service. Typically, clients provide us with a statement of work. In this particular case, we have broadly looked at 9 disruptive technologies. In the second step, our team has a teleconference similar to this webinar, but where we would have interactive discussions with you and your teammates on the findings. And then, in the last step, we compile our findings into a report for you and your teammates to disseminate internally.